Myself is Prabhakar. For BSc Electronics, first semester, University of Mysore. This is the second session. In the last session, I explained the Kirchhoff laws. In this session, I will explain the mesh analysis method. This method is used for solving any electrical network. The definition of the mesh is, it is a loop that contains no other loop within it. Mesh analysis method uses Kirchhoff's voltage law to determine the unknown currents in the given network. Mesh analysis is also called as mesh current method or loop analysis method. Next, to analyze the DC circuit by mesh analysis method, first identify the independent meshes in the given network. Step 2, assign a circulating current to each mesh. Step 3, write the KVL equation for each mesh. Step 4, solve the KVL equation either by elimination method or by Cramer's rule to find the unknown mesh current. Using them, the required branch current can be found. Analysis of DC circuit by mesh analysis method. Let I1 and I2 are the currents in the loop 1 and 2 respectively. Apply KVL to the loop 1. I1 into R1, that means I am starting from this point. I1 into R1, the current I1 is flowing like this, plus I1 plus I2. I2 means the current flowing in the mesh 2, in the loop 2. I1 plus I2 into R2, that's equals to E1. That means the source voltage from negative to positive, the rise in potential, you must take positive, this side equals to E1. I1 into R1 plus R2, that's equals plus I2 R2, that's equals to E1. Say equation 1. Apply KVL to the loop 2, I2 into R3. That means I am starting from this point. The current is I2 is flowing like this. I2 into R3 plus I2 plus I1. I1 means the current flowing at the mesh 1. Loop 1, I2 plus I1, I1 plus I2 into R2, that's equals E2. That means from negative to positive, the rise in potential, you must take positive this side, that's equals to E2. Next, I2 into R2 plus R3 plus I1 into R2, that's equals E2. Say this equation 2. Solve the KVL equations either by elimination method or Cramer's rule to find the unknown mesh currents. According to this rule, the equation Cramer's rule, the equation 1 and 2 can be written in the matrix form as, in this, we have the left hand side of the system with the coefficient matrix. That means I1, the coefficient of I1 and I2, and the right hand side of the system with the answer values. That means E1 and E2. Let delta be the determinant of the coefficient of matrix of the above system. Let delta I1 be the determinant of the matrix formed by replacing the first column values of the coefficient matrix with the answer column values. That means the determinant of the matrix formed by replacing the first column values. First column values means this one, first column values is replaced by the answer values. Answer values means E1 and E2. Next, delta I2 be the determinant of the matrix formed by replacing the second column values of the coefficient matrix with the answer column values. That means second column values means this one is replaced by the second column and by the answer column values. Answer column values means E1 and E2. Next, the mesh currents I1 and I2 are given by I1 equals to delta I1 divided by delta. Next, I2 equals to delta I2 divided by delta. Problems on mesh analysis method using KVL. In the following network, calculate the currents and the potential difference across 2 ohm using mesh analysis method. The given network, let I1 and I2 are the currents in the loop 1 and loop 2 respectively as shown in the figure. Apply KVL to the loop 1. So I1 into R1, that means I am starting from this point, means I1 into R1 plus I1 plus I2 into R2, that's equals to E1. Next, I1 into 1 means R1 equals to 1 ohm, I1 plus I2, R2 equals to 3 ohm, that's equals to E1. The source of E1 equals to 2 volts. 4I1 plus 3I2, that's equals to E2. Say this equation 1. Apply KVL to the loop 2. I2 into R3 plus I1 plus I2 into R2, that's equals to E2. I2 into 2. R2 equals to 2 ohm. I2 into 2 plus I1 plus I2 into 3. R2 equals to 3 ohm. That's equals to E2. E2 means second source. Second source E2 equals to 4 volts. That's equals to 4. These two equations can be written, that means equation 1 and 2 equation can be written in the matrix form. As in this we have the left hand side of the system with the coefficient matrix, that means the coefficient of I1 and I2, and the right hand side of with the answer values. The answer values means 2 and 4. Let delta be the determinant of the coefficient of matrix of the above system. That means the determinant of the given matrix delta 4 into 5. 5 4s are 20 minus 3 3s are 9. For 20 minus 9, that's equals to 11. Let delta I1 be the determinant of the matrix formed by the replacing first column. First column means 4, determinant of the first column 4 3, delta 4 3 is replaced by the 2 and 4, is replaced by the 2 and 4, this column. 2 and 4 is the answer values. So 4 into 2 into 5, 2 into 5, 10 minus 4 3 is 12, 10 minus 12, that's equals to minus 2 amp. Delta, next, delta I2 be the determinant of the matrix formed by replacing the second column values of the coefficient matrix with the answer values. That means second column values means 3, 5 is replaced by the 2 and 4. Answer column values 2 and 4. The determinant of the given matrix is 4 into 4, 16 minus 3 2s are 6. 16 minus 6, that's equals to 10 amps. The mesh currents I1 and I2 are given by I1 equals to delta I1 divided by delta. You know the delta I1 values. Delta I1 equals to minus 2 amp. So minus 2 divided by delta. Delta equals to 11. Minus 2 divided by 11. That's equals to minus 0.18 amp. Next, I2 equals delta I2. You know the divided by delta. You know the delta I2 equals to 10 amp. So 10 divided by 11, that's equals to 0.9 amp. And finally, we must calculate the potential difference across 2 ohm is I2 into 2. So you know the value of I2. I2 equals to 0.9 into 2, that's equals to 1.8 volt. That means the potential difference across the 2 ohm is 1.8 volts. So by using this mesh analysis method, that means this method is used for solving any electrical network. Thank you.